And welcome YouTube squad. Here is today's daily space and earth weather stream starts out here on the trail. So it's a clandestine trail, that's hence the title of the video. And this is all I'm going to show you. Yeah, it's a secret trail, so I won't be divulging where it is because, you know, you should have some secret trails that people don't know about. Hence the use of the term secret. But it's a good one. And I know for a fact that usage is minimal. So being a mountain bike racer, the first racing I ever did actually was mountain bike racing. And I'm a trail connoisseur. One could even say a trail elitist. And remember, folks, you can always be elite without being elitist. But yeah, I have certain preferences for the trails that I use. And one of the most important features is that it's kind of, not that well known. Those are all the best trails. And a lot of times you'll find secret trails that are built on to trails that are obvious trails. So we did another stream earlier today about whether or not the sun is conscious or sentient. If you haven't checked out that live stream, make sure you check it out. If you're new to the channel, make sure you press subscribe. Otherwise, you may not see the world's most comprehensive daily space weather content delivered right to your inbox. So I'm going to keep the camera at this weird angle here because, again, it's a clandestine trail, and I don't want to divulge where it's located. But in any case, we'll be talking about earth weather and space weather, and my hands are freezing. It's like 20 degrees right now in Lehigh Valley, PA. And that's a little bit too cool for comfort. So one hand goes in the pocket, one hand goes on the device. And my face is slowly freezing. So I'll be getting into the studio location here shortly, following my short stint on the clandestine trail. So yeah, we got an uptick in solar activity in the past couple of days because of some rising sunspots on that eastern solar limb. We'll be talking about those, the likelihood of flares, coronal mass ejections, coronal whole high-speed streams, the magnetic environment, and so forth. So yeah, standard stuff. We'll show some weather forecasts toward the end of the stream. So let's get started by getting indoors. That way I will not freeze into a solid block of ice, which is the path I'm on at the moment. So I've got to start my temperature going. I make some highly specialized sandwiches, and you can find stuff about that on Instagram. So anyway, let's get in front of the PC so I can tell you what's going on with Helios, El Sol, the closest star, the local yellow dwarf, the sun, whatever you'd like to call it. I forgot my tripod. And I could use my coffee too, that'd be good. Fantastic. Now we're in business. So pull up your favorite morning beverage, unless you're viewing from some other part of the world. Then pull up your favorite whatever kind of beverage and join us as we talk sunspots and related things. All right. And welcome to the Smash News Network, these busted naming news. I've made it without freezing into a block of ice to the studio, so that's good. It's Starting out cold day in the neighborhood. A starting cold day in the neighbors. Freezing their minds. Hopefully they're not ossified in their beliefs, folks. Hopefully they're not ossified in their beliefs. You know, because in the realm of science, what we do is we see the natural world and we go, huh, how is that a thing? And then we come up with plausible explanations, you know, explanations that are plausible in terms of being believable physics and things like that. And then we test them. We try to disprove our own hypotheses. And then, you know, if we don't disprove our own hypotheses, then we share the information with colleagues and we ask them what they think and see if they can disprove our hypotheses. And if not, it could be a real theory. All right, so here's the closest star. What we don't do is we don't get outlandish theories for things and then search and cherry pick to try to make our theories right. That's not how science works. You try to disprove yourself because you don't want to waste your time with scientific dead ends. All right, so there's the closest star. And yeah, like I said, we have these two new active regions. This one down here is quite complex. It's got a number of umbrae, and we have some lunar eclipses going on there at the GOES 19. That's why you see that enshadowing. And there's a little CME popping off there and a solar prominence at the end of the video. Background X-ray flux. What do you got? What do you got? The background flux for the past day is in a low-level C class background flux. I'm sorry, a high-level B class, about a B 8.5. So pretty low solar activity here despite these new spots. Let's take a look at them from SDO's spectacular HMI instrument. And there's the latest. Showing you 171 plus HMI here. That's extreme ultraviolet. Ionized iron there is the gold part. And then the black and white part is the solar magnetogram. Nah, it's not that magnetically complex. So it's a beta class sunspot group. This is I think that might be only an alpha class. Nope, that's a beta class sunspot group as well. But not magnetically complex. So the likelihood of large flares, not really there. There is a new sunspot rising here as well, it looks like. Can we already see that on the continuum? Indeed we can. So sunspot number will rise once again today. Cosmic ray flux remains at a 22-year low. Lowest cosmic ray flux we've seen since solar cycle 23. And we're talking peak solar cycle 23, which means solar cycle 25 is a stronger cycle than solar cycle 23. One of our producers of cosmic ray flux is Cygnus X3. There are its X-ray outputs for the past 20 years, for the past 30 days, and for the past day. Cygnus X3, high mass X-ray binary. It's a weird object. It's basically what Cygnus X3 is it's a white dwarf companion star that is orbiting a much more massive star, a thing like a neutron star, at a very close distance with an extremely eccentric and extremely fast orbit. And then there's a plasma disk in between this more massive object and the white dwarf. And the plasmoid in between the more massive object and the white dwarf has two radio jets that emanate from it, and one of those is oriented directly toward Earth. So it's 32,000 light years distance. And Cygnus X3, read about the little friend. There are many articles about it. When it was discovered, people were like, what the heck is this thing? Cygnus X3, one of the weirdest objects and the most pertinent objects in the Milky Way galaxy. The only known cosmic ray point source. It's wild. Do we have any more earthly directed CMEs? Well, let's see what the Hux forecast has to say about it. And it looks like no new CMEs there on the Hux forecast
from University of Reading. I'll let it play through once more and then move on because there's no there. That's your forecast through March 6th from U Reading. So next, the ACEN discovers data here at the Lagrangian point 1. They're located right about here, about 1,000,000 miles, 1/93rd of the way to the sun approximately at Lagrangian point 1. Current solar wind conditions are nominal. 441 kilometers a second for the velocity, solar wind density about 1.25 protons per cubic centimeter, and the magnetic fields are only 3 nanotesla with a BZ of -1. NOAA's not forecasting any major space weather here. Let me press refresh. No major space weather in the forecast there. No geomagnetic storms expected. Here's what the magnetosphere looks like for the past about 4 hours. It's croissant Earth, folks. So the sun would be off in this direction. Here you've got the equatorial plane. Here you've got the meridional plane, like Earth from the side, Earth from the top, if that makes sense. And yeah, that's calm conditions for space weather. Radio flux is up to 130 solar flux units now, as reported by Solon.info. And the sunspot number now down to, well, I mean, I should say up to. What do you got? Up a little bit from yesterday here to 35 sunspots. Make it 42 sunspots. 42 sunspots, we'll say. There you go. There's the Royal Observatory Belgium report. David Bielski 3484 says, OMG, that's good to hear. Great. I don't know what's good to hear, but fantastic. All right, so here's the GOES 19 coronagraph. We'll check and see if there are any new CMEs likely on the way. We do have the moon moving through here and creating a lot of high contrast, because this is designed to view the solar corona, a thing as bright as the moon moving through. It affects things a lot. So we'll briefly look at stereo A here because, well, frankly, that GOES coronagraph sucked. Let's take a quick look at stereo A's coronagraph. It gives us a little bit more angular of a view. If you see CMEs going off toward my pointer here, that would be where Earth would be located from the perspective of stereo A, off to the left of the obscurement disk. The white circle represents the solar chromosphere. That's like the surface of the sun. So yeah, it doesn't look like any new Earth-directed CMEs are on the way, unfortunately. So sorry for all you aurora chasers. The likelihood of mid-latitude aurorae is not there. That Earth isn't going to be burned up by a solar flare anytime soon. So here's the thing about solar flares. Earth is never going to be burned up by a solar flare because solar flares are X-rays and they don't burn up the Earth. So when a solar flare hits, the X-rays don't even make it to the surface, and a solar flare cannot burn up the Earth. It's impossible. That is not a thing. So definitely don't worry about a solar flare burning up the Earth. X-rays are not going to burn up the Earth. They don't even make it to the ground. They're filtered out by the stratosphere level. So they're completely absorbed. They're not even detectable at the ground. So solar flares are not going to destroy civilization, the planet, kill you, anything like that. If there's a channel telling you otherwise, they're blowing smoke up your posterior. So here is the current situation for planetary locations. Please refresh, you son of a piece of sh. Good God. All right, there we go. Thank you, server, for answering my request. theplanetstoday.com. Here is it's Jupiter's in retrograde. Oh my God, Jupiter's in retrograde, and it's going to be in retrograde for a long time. But yeah, that's where things are. Mercury is speeding up on Earth, blasting. It's about to blast past the fastest planet there, folks. The GOES proton flux not showing any significant proton spikes there, just a couple little minor changes from baseline. That's not noteworthy. Like I said, the background X-ray flux is at about a B8.5, B9, something like that. So very close to a C-class background flux. And we've got another sunspot, so we may get into the C-class background flux. In fact, very close to it now. Next, the heliosphere and the magnetism therein. Here's yesterday plus today as Earth moves toward that South Pole-oriented magnetic sector shown in red, where Earth will cross a current sheet out of the North Pole sector, another current sheet into the South Pole sector, and then Earth's magnetosphere will be connected to a South Pole magnetic sector instead of a North Pole one. Here's the coronal hole situation. We've got this North Pole-oriented coronal hole. That's what's coloring the magnetic sector green. That's for north. Those magnetic field lines are open, and they extend all the way out into space to Earth and beyond. These magnetic field lines are oriented toward Earth. The South Pole-oriented ones are oriented toward the sun. Next, how about some ground-based magnetograms? I'm just going to bring up the last image here to get a quick look at these. So these are the important sunspots. Again, the likelihood of large solar flares is not there. These are not magnetically complex sunspots that demonstrate what we call beta gamma delta class magnetic fields. So here is there's the ground-based red light imagery. There's the latest from Cerro Tololo, Chile, located high in the Atacama Desert. Last but not least, plasma filaments. There's the hydrogen alpha imagery. It shows these same features. You see these bright features that are hanging off the edge? Those are solar prominences. They are also solar filaments. So these features are the same as these features, just from a different perspective. They show up as absorption features here because they are a chemically rich cocktail. However, they have a lot more hydrogen than the background outer space hanging off the edge here. So you see hydrogen here, you see less hydrogen here. That is why this appears dark. This is an absorption feature when it's on the disk because it's reducing the amount of hydrogen spectra that gets to us. When it's hanging off the disk, it's increasing the amount of hydrogen spectra emitted by empty space. Does that make sense? We're analyzing the sun. That's the sun, the local yellow dwarf L Sol Helios. And let's move on. By the way, make sure you follow us on X. If you don't follow us on X, you're going to miss a bunch of exclusive stuff. There is a lot of science debunking on X. And did you know that you can even get on our skin suits this year? Yeah, there's SNN branded stuff coming out this year, and you'll be able to get cycling kits that actually have the info on it. So anyway, yeah, make sure you follow us on X or you'll miss out on all kinds of stuff that has nothing to do with this YouTube channel. Well, I guess there's something to do with it, but yeah, it's whatever. The electron storm continues. There's the GOES electron flux measured at the F layer of the ionosphere. If you want to read about this, just click on details. It'll tell you what's being measured and what's doing the measuring and so forth. But yeah, electron storm continues. Expect bad performance from your GPS. The coupled thermosphere, ionosphere, plasma sphere electrodynamics total electron content forecast will agree with me. A lot of red on there. These are the areas, like sands through the hourglass of time. These are the areas where you can expect bad GPS performance. It could be off by thousands of miles, so just be aware of that if you're relying on your GPS to navigate during electron storms. Again, the likelihood of large solar flares really is not there, so don't expect major radio blackouts. We ain't got no super complex, super active sunspots. This is just a diagram of the ionosphere to show people the altitudes of things, like the F layer and the D region and so forth. Just a quick reminder that space weather starts here at the D region. From the D region to the sun, that's the mostly ionized atmosphere, Below the D region is where Earth weather happens in the mostly neutral atmosphere. Roger Cheeto 1 says, what have you studied for this? Physics for my entire life, and astronomy, astrophysics, cosmology, etc. So here's the ionosphere. This is the Australian Government Bureau of Meteorology. We're going to just refresh that to make sure we have the latest. This is showing you the vibrational frequency up there at the F layer. So again, there's the diagram. The F layer is between about 160 kilometers and 300 kilometers in the daytime, or 400 kilometers in the daytime. And then at the nighttime, it's a thinner layer as it puffs down. Anyway, this is showing you that in a different sort of format. It's showing you the graphical format there in megahertz. That's millions of vibrations per second. That's the vibration of the F layer. So as you can see, it gets excited in the daytime and it calms down at nighttime, and then it repeats. Here's the anomalygram, anomaly in megahertz from a 30-day median. It does a great job of showing you the South Atlantic anomaly, which is actually at the equatorial Pacific here at the west coast of South America, and it shows you the African anomaly here on the west coast of Africa. So this is the weakest point of Earth's magnetosphere right in here, and there's another weak point over here, but it's not as weak as the South Atlantic anomaly, which again is actually on the Pacific west coast, right on the equator practically, right about there, just off the equatorial coast of South America. The South Atlantic anomaly, folks, it's moved a lot, and over the years we've covered it on the channel, and no, it doesn't spell doomsday. It's part of pole shift, and the poles are always shifting because this is a function of Earth's magnetosphere, folks. And let's get to Earth weather. Since we brought it up briefly, here is the Atlantic sunrise. We show it daily on the channel, most days. And there it is, from the lovely GOES Interactive Weather Satellite Suite. It's the visible satellite that goes east, folks. So good, that it makes me want to join the Croissant Earth Society. Did you know that Earth is actually shaped like a croissant? Yeah, there's a lot of lies out there on the internet. Why do you believe NASA's lies? What, do you think Earth is shaped like an oblate spheroid? What are you, some kind of psycho? Everybody who watches our channel knows that in the description, there are links to our Redbubble shop. So support the channel by picking up some merch. We don't meme troll the way your average noob meme trolls. We take it to another level. We even take submissions. So if you have an idea for a thing, let us know, especially on social media like direct messaging. There's all kinds of ways to get a hold of us, folks. Links are in the description to the shop, to the homepage, to the Discord channel, and so forth. So in the meantime, we ask you, when will you stop believing NASA's lies and understand the Croissant Earth Society, and that Earth is clearly shaped like the French breakfast pastry? Duh! Next, moving on with Earth weather here. Here is the water vapor map for the U.S. as atmospheric rivers continue to wash ashore on the Pacific coast. This is why the Pacific coast is so moist, folks. So I'll show you the GOES west. Okay? I'll show you the GOES west. Because the Pacific Ocean is a giant water machine. It's, the biggest body of water in the world. So it's constantly pumping water and creating these atmospheric river flows. Right now, there's a huge anticyclone there surrounding an upper level low. It's a very exotic thing right there, because you've got this counterclockwise rotation, but all this dry massive air wants to rotate clockwise, because this is really an anticyclone, much like this one, but it's not. This one's actually trying to rotate, but this one here, it's just constraining this area of more moist air. So this upper level low is it's very powerful, but there's not a big pressure gradient there because there's insufficient moisture. And this is acting as a blocking feature. It's going to sort of prevent most of this moisture from even mixing in. So this moisture is going to loiter here in the Pacific because of this dry massive air that's acting like a wall. But on this side, you've got it pumping. Again, dry mass of air acting as a blocking feature. You can see the way it's basically splitting the air right at this point. If you understand the way the water vapor map works, the Doppler will never be a mystery, and you'll probably not believe in chemtrails. We hope you don't believe in chemtrails because it's like super pathetic. While we're here, let's show the long wave infrared map. I guess the clean one for the US. This is more of a standard weather map that you may see on, like, regular weather channels. And this is just showing you the infrared radiation emitted by water. It's 10.35 micrometers. And yeah, for example, there's a bunch of evaporation happening here east of the Yucatan Peninsula. That's why you see all of this. You see the way there's no water vapor here, and then there is water vapor? That's because of evaporation, folks. See that? A prime example of evaporation. See, physics, it's you can use deduction to figure out where those clouds came from. It's because the water underneath there is kind of warm. Anyway, I can't believe I got to say that. But yeah, there are a lot of people that are mad at clouds, and frankly, it's disturbing. People think that clouds are man-made and things. It's pretty bonkers. All right, so yeah, there's a great example. You can see this super dry air here, and then you can see the air is getting more moist because ocean water is evaporating. It's incredible the way physics works as everything in the universe tries to reach static equilibrium. All right, so we got some warm days coming. Shout out to all of our local viewers. It's about 30 degrees out right now. It felt colder than that, but we're going to have a high about 46 today, and tomorrow a high near 51. So if you're thinking about doing some bike riding, highly recommend it. It's going to be pretty sweet. There is a Ride Leaders meeting. So if you're in the Lehigh Valley Cycling Club, maybe attend, become certified to lead rides. We need more ride leaders, so why not become one? You won't have to enter French fry mode like me. I'm in French fry mode, but you don't got to be in French fry mode to be a ride leader. It's pretty easy. Basically, you join the club, you make people sign a thing, and then you behave rationally. You give people good advice. You have good routes. You signal. You get along with motorists. You let the fastest entity go up the road, follow the basic rules of the road and things like that. It's spectacular. But yeah, we always need ride leaders, folks. The club hosts hundreds of bike rides per year, hundreds. Probably something like, 500 rides a year or something. So some nice weather coming to the U.S. Here is the Doppler radar map, and we've got a bunch of moisture here in the southeastern U.S. Hey, Montgomery, your heavy weather is ending. It's going to taper off. And you'll see scattered showers for an extended period, but the heavy stuff is on its way out. So yeah, that's what's going on for current weather conditions. We'll show a brief forecast as some lake effect snow continue to batter parts of New York, and the area east of Ontario is pretty snowy. Pretty freaking snowy. Look at the snow cover over here. 43.9 inches. That's quite a bit of snow. It's definitely a good spot for snowmobiles and snowshoes and cross-country skiing. It's a freaking winter wonderland. And most of Pennsylvania is also white. Anyway, there's your snow depth map. Let's show a lightning map, as we do have some lightning as things warm up. Some lightning here. It looks like there's thunder rolling in somewhere. Waynesboro. And anyway, those places. It's a real-time lightning map from lightningmaps.org. Highly recommend. Don't be a son of a bittern. Know where the active cells are. All right, so Tropical Tidbits. We are in our final segments here, folks. We're just going to show a snow, total accumulated positive snow depth change forecast. Here comes the GFS model in inches. There it is. There you have it. So warm days coming and some more snow coming, especially north of the Blue Mountain for Pennsylvania. As a little Alberta Clipper makes its way through North Dakota and Minnesota, Wisconsin, across the Great Lakes and so forth. Well, there's the freaking map. Why am I trying to explain it? I'm showing it to you in graphical form. Let's look at the Earth's wind patterns and close this mother out. Here is the jet stream scenario for the Eastern world. Shout out to our viewers from Munda and from way over there. Here are your surface winds. Surface winds of the Near East, Africa, and Europe. Jet streams. That's the 250 hectopascal winds, the 250 hectopascal winds. And here is the West. The West's jet streams. Doubled up over the western U.S., converging over the western Atlantic. Here are the surface winds of this side of the world. We'll close out with more solar imagery. Let's take a look at 131 angstroms. One of the great wavelengths through which to view flares, solar flares, when the sun has a burst of X-ray flux. So there's 131 angstroms, and that's not too bad. That's not too bad. We do have some plasma instability around these sunspots, so that's a good thing. But they're not particularly volatile in terms of their magnetic fields. So again, like I said earlier, the likelihood of them producing large flares is really not there. God's speed says interstellar travel. Okay, you've typed a buzzword in the comments, and thank you for that. So here is the 171 angstroms. This should also show those plasma filamentary instabilities. Let's look closely. All right, so it just refreshed too, so that's perfect. Great view there of the middle corona, 171 angstroms. It's great at showing the magnetic filaments. You can see all of those field force lines there around which that ionized iron likes to orbit. This is the transitional middle portion of the corona, not to be confused with the lower corona or the outer corona. And this transitional portion of the corona really likes it likes to organize this species of ionized iron into these magnetic field lines. So you see great representations of where the field lines are located there. And by the way, if you look at the SDO, and by the way, don't forget to check out our homepage, smashomash.com. But if you look at the SDO page, you can actually look at those field lines. Where is the link for it? There we go. There's the sun now. If you scroll down and you click on the non-colored magnetogram, it's going to show you some field lines there. We've got actually two named sunspots there, 4379 and 4380. And what's cool about the HMI instrument is that it's attuned to the photosphere. So these are deeper magnetic field lines than what you're seeing on here. So these are magnetic field lines that are emanating from the middle corona, because that's the majority of what the 171 angstroms wavelength shows. It does show some out, further out corona, obviously, but the HMI instrument is attuned to the photosphere. So these are more direct magnetic field lines for the actual sunspots. I'm going to actually bring up a smaller, bring up the 1024, so it's not quite so massive. There we go. So, and as you can see, there are some interactions here where this, there's a field line looking like it's anchored way over here and things. And basically what happens, folks, is sunspots feature a bunch of really jumbled up field lines, the opposite of a coronal hole, which has field lines that point all the way out into space. Um, these are closed magnetic field lines. Coronal holes are open magnetic field lines. And that is a huge difference. You can also, there are some other really cool spectra you can look at, like you can put 171 angstroms along with it, and that's a great view of those sunspots as well. But yeah, so let's close out with 195 angstroms. It's pretty good at showing filaments, so I'll let that play through here for a minute. God's speed. If you're leaving a comment from a different star system, or if you're from a different star system, make sure you let us know in the comments there. Like if you're typing the buzzword interstellar travel into the chat because you've interstellar traveled, then let us know where you came from. And don't forget to share your spacecraft schematics. Make sure you include technical diagrams of your spacecraft on the Discord chat, which is linkable, by the way, right on our homepage, smashomash.com. So let's by the way, this is depicting like 12 hours at a time. We're just zoomed in here because we ought to be. All right, so last but not least here, we're going to show the 304 angstroms wavelength fixated on this eastern limb because there's a big prominence there and it's just good stuff. So this is the last about 12 hours of the east side, and we call this the east side of the sun because this is where sunspots rise. The sun rotates kind of this way, and where the features set, that would be the west. Where they rise, that would be the east, obviously. And so, yeah, there's some plasma instability there. A new sunspot rising as well. So expect an ongoing minor uptick in solar activity here in the coming days. So no major space weather on the way, but a little bit of an uptick there. So for everybody who's spooked of very low sunspot numbers, you can come back out of the bunker now because we are really close to solar maximum yet. We're not even 18 months away from solar maximum. We're only about 16 months from solar maximum right now as the solar cycle ramps down. And you can expect a whole bunch of exciting stuff to happen between now and solar minimum. At solar minimum, don't expect a lot of action, but remember, folks, we don't need sunspots. We don't need solar flares. Coronal mass ejections happen all the time. We don't need coronal holes. Space weather happens regularly, even at solar minimum. Coronal mass ejections still happen sometimes. There's just less of them at solar minimum, and the sun's not shutting down, and the sun is not going to end civilization. So, like, all of the here's extraordinary claims require extraordinary evidence. While our finest days lie ahead, the doomsday prophet circuit just lies. So anyway, that's where I'll close things out. And thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, aka Smash-O-Mash, signing off. And until next time, may that nominal solar wind be at your back. Reminder, this video is for live stream purposes only and may not be reproduced or stated by any utter morons on the internet. Any fine print at the end of this video will not be transcribed by YouTube. If you do not press the subscribe button, you may not see the world's most comprehensive daily space weather content delivered directly to your inbox, so make sure you press the subscribe button and like. And also visit the links in the description, otherwise these videos may not continue to exist. We thank you for your patronage here at the Smash News Network, the trusted name in news.